Welcome to part 6 of this WiseL tutorial series on SQL Server 2016. This video is going to look at the basics of designing and creating a relational database. Now there are lots of steps involved in this video, but we're going to start by creating a really simple single table with a couple of rows of sample data. And that gives us the chance to start the process of normalising data, which is really the formal name given to separating one large table into multiple component parts. So we'll go through that process by identifying repeating information in a single table, then talk about creating multiple tables to separate that repeating information out. We'll talk about assigning primary keys and identity columns to these multiple tables, so that we have a way to uniquely identify every single row in a table. Then once we've done that, we'll talk about creating foreign key constraints and relationships between tables. We'll show you a nice diagrammatic way to build those sorts of relationships, so sort of a graphical tool called a database diagram, which is kind of a fun way to build up a database. And while we're talking about database diagrams, we'll discuss one-to-many relationships and many-to-many relationships, and how you can model a many-to-many relationship, by using something called a junction table. So quite a lot to do here, let's get started. The previous video in this series looked at how to design a single, simple table in SQL Server, and the primary focus of the video was on creating or choosing the correct data types for the individual columns. Now in the real world, it's highly unlikely that the databases you'll work with will contain just one single table. It's much more common to have a database which contains multiple tables all related together in some way. So this video is going to focus on the basic principles of relational database design. We're going to get started by creating a brand new blank database. So we're already connected to our SQL 2016 training instance, which is the instance of SQL that we installed in the first video of the series. And we're logged in as a system administrator, which means we can create new databases freely. So I'm going to right-click the databases folder and choose to create a new database. In the dialog box that appears, I'm going to call this database people, just the same as we did in the previous video. Now if you already have a people database, you won't be able to create another one called people, so you may well need to delete the existing people database first. But as long as you don't already have a database called people, you can click OK, and that will generate the new database. You can expand the databases folder, and you should find the people databases sitting there. The next thing we'll do is create the main core table of this people database. So this table is going to be called person, and the idea is that each individual row in the table will contain data about one single person. So let's head into the people database and find the tables folder in there, and we can right click on the tables folder and choose new table. This will take us into the table design view, just as we looked at in the previous video. So let's just quickly go through and create a few basic columns. These will be quite similar to the columns we created in the previous video. So I'm going to create one called first name and then hit enter. We'll have one called last name and again hit enter. I'll just make sure I'm using the correct naming convention here, Pascal case, so we need a capital N there. And we'll have a column that contains the person's title. And then we'll also have a column which contains the person's date of birth. And then we'll have another column which contains the company you work for. And then finally we'll have one more column that contains information about, let's say, what hobby you do. So what you do in your spare time, other than watching SQL Server training videos, of course. So those are the first few main columns we'll create. We should also choose sensible data types for each of these columns as well. We talked a lot about data types in the previous video, so not going into too much detail here. For the first name and last name, I'm going to use nvarchar 50, and we'll use that data type for both of those. Then for the title, I'm just going to, for the time being, I'm going to use nvarchar. In fact, we're going to stick with nvarchar 50. There's not much point in changing that at this point. Date of birth, hopefully, obviously, will not be just raw text data. We're going to use the date data type. And then we'll have the company, which will be, again, nvarchar 50 for the time being, and likewise the hobby, nvarchar 50. The allow nulls column, we don't want to allow nulls for the first name. We should always at least enter somebody's first name. But for the time being, I think each of the other categories of information we might not know or have the values to hand, so let's allow all the remaining columns to be null. So at this point, let's save the table to get it created, and then let's start entering some sample data into it. So to save it, I can either click the Save button or press Ctrl and S on the keyboard. I'm going to call my table person, because each row in the table represents a single person, and then click OK to create the table. We should find that table exists now in the tables folder, so if I expand the tables folder of the people database, if you find, like me here, your table doesn't appear automatically, you can right click on the tables folder and choose refresh, and then your table should appear. Now, to enter some data into the table, one simple way to do this is to right-click on the person table and then choose Edit Top 200 Rows. If you do that, you'll be taken into the table datasheet view, and we saw this again in the previous video, but we're ready now to start entering some data into the first row. So let's just enter a bit of sample data. I'm going to enter the first name of the person as my own name, so I'm going to put in Andrew, and then the last name is Gould. Title is just a lowly Mr. I did actually study for a PhD, but I never got around to writing the thing up, so I never got my doctorate, so just a lowly old Mr. for me. My date of birth, I'm going to pretend that I was born much later than I actually was. Let's say I was born in 1990, on the 1st of January. That's significantly later than when I was actually born, but there we go. The company I work for, of course, is Wise Owl Training. Sorry, not Wise Owl, Wise Owl Training. And then finally, I can enter a hobby. What's my hobby? If only I had time for hobbies. Let's say my hobby is making YouTube videos, making training videos. There we go. That's a bit of a sad hobby, but there we go. I'm just going to widen some of these columns so you can see a little bit more clearly what data I've entered into here. And then if I were just to either hit enter or click onto a different row of data, as we discussed in the previous video, that will commit that record to the database, or commit that row to the database, I should say. Having entered the details for one single row, I just want to add one more sample row. So I'm going to enter the details for one of my colleagues, Andy Brown, who's, you may have seen some of his videos actually. He's made a couple of series of videos as part of this channel. So let's enter Andy Brown into the database, and he's a Mr. as well. And then let's have a date of birth. Oh, he's much older than I am. Let's say he was born in, let's say, 1950-01-01. That's not his real date of birth, but he'll be quite upset if he sees this, but there we go. He also works for Wise Owl Training, so at this point I'm going to have to type in Wise Owl Training again, which is already kind of tedious. I'm finding that a little bit annoying already. And what's his hobby? Well, he's got 3 children, so he doesn't have time for hobbies. Let's say that his hobby is, I don't know, ferrying kids to, I don't know, events. That's his hobby. There we go. Now, if I hit enter at that point, I can enter that second row of data into the database. Now, even having entered just 2 rows of data into this table, I can already start to spot a couple of potential problems with the way we've organised the data. So in a couple of columns I've had to enter the same value more than once. For instance, in the title column, I've had to enter the word Mr. a couple of times, which I appreciate isn't that much of a hardship, just to type in 2 characters a couple of times. But the more I have to do that, the more tedious that's going to become. And for longer titles like Doctor and Professor, if I know any doctors and professors, that's going to become even more tedious. So entering the same value more than once is wasteful in terms of time entering the data. But there's also a problem if you go to the company name column, for instance, where the problem's exacerbated. For potentially rubbish typers like me, entering the same value more than once in the database leads to the potential for making input errors. So for instance, if I transposed a couple of characters here, maybe I entered Wise Owl Training as Wise Owl Training, that gives me a problem later on in the database if I come to search for all the people who work for Wise Owl Training. There's also the potential that maybe the Wise Owl Training company name changes at some point in the future. Maybe, I don't know, let's say Wise Owl Training branches out or diversifies into, I don't know, selling pogo sticks, for instance. So, I have no idea why I picked pogo sticks as an example. Wise Owl Training becomes Wise Owl Pogo Sticks. That means that for every individual person who works for Wise Owl Training, as was, needs to have their company name updated to Wise Owl Pogo Sticks. Now, that's a potential problem, because that means that I've got to go through the entire table to find every single individual who works for Wise Owl Training and update that manually. Storing the same value multiple times as well is wasteful in terms of storage space. So if you remember from the previous video, we talked about the idea that different data types require different amounts of memory to store. So Wise Owl Training is nvarchar data, and nvarchar data requires an amount of storage space that's equal to twice the actual length of the strings. That's about 17 characters in this case, multiplied by 2, so that's 34, plus an overhead of 2 bytes to deal with the variability in the length. So that's 36 bytes for each time I store Wise Owl Training, which in real terms doesn't sound like an awful lot. 36 bytes to a computer isn't that much. But if you multiply that over the potentially millions of rows of data in an actual SQL Server table, that becomes ever more of a problem the larger the table becomes. And this problem kind of carries on over into the hobby table as well, or the hobby column, I should say. So although I'm the only person in this current set of data who makes training videos as a hobby, and Andy's the only one who ferries kids to events, it's certainly possible that multiple future people we add into the database will have a similar hobby or the same hobby, and having to enter these values again multiple times is going to cause us the same sorts of problems. Now, a way to solve all the problems I've just described here is to essentially reorganize the way this table works, so that we're not storing the words for the titles like Mr. and Mrs. etc. We're not storing the company names and other company details, and we're not storing all the hobbies all in the same table. The idea is to find the repeating data in your database and split that data out into multiple different related tables. Now, the fancy posh word for this process is referred to as normalising data, and you can read all sorts of detailed technical articles about normalising data in the first and second and third normal forms. All I'm interested in here in this video is showing you how that process works in terms of designing a SQL Server database. So to start with, let's just close down this table with its simple 2 rows of data in it, and we'll take us back to the design view. If you've closed that down, you can just right-click on the table again and choose to view its design. Now, because we're not actually going to be storing the title and company name and hobby name in the people table, or the person table I should say, what I'm going to do to start with is just delete those columns from the table design. So I'm going to right click on the little grey box next to the column and then choose to delete it. So I'll do that for the title and for the company and for the hobby. And yes, this is also going to delete the actual data that's stored in those columns as well. If I save the table at this point by hitting the save button, and then I right click on the table again to view or select, or sorry, beg pardon, edit the top 200 rows, I'll see that those columns and the data that it contained have all disappeared. But that's fine, we've only entered a couple of rows of data. In the real world, normally what you'd be doing is designing your database properly in the first place, rather than reorganizing the design of an existing table. So you won't encounter this problem where you're deleting data that you've already entered. What we're going to do next then is, for each of the columns we've deleted, we're going to replace them with a reference to another table. So let's start with the title table. This table is going to contain just a list of all of the possible individual titles that we might want to assign to a person in the database. So we're going to create a new table in Design View, just as we've done previously. I can right click on the Tables folder and choose New, and then choose Table. Now, this table is actually going to contain 2 separate columns. Of course, it will have the column which contains the actual text of the person's title, so it will contain, for instance, the word Mr. and Mrs. and Ms, etc. But it will also contain a column which stores just a single number. The important thing about this number is that it will be unique to every single row in this table. So traditionally you would call this column something simple like ID. You will also see in other databases that you prefix the ID column with the name of the table to which it belongs. So in this case we might call this title ID, just to distinguish it from all of the other ID columns that we're going to generate. So title ID for this column, the important thing is, as I said, it's going to be a number. Now, it doesn't have to be a number technically, but numbers are traditionally what you would use for this identifier column. So we talked about different data types in the previous video, of course, and we talked about the various different numeric data types. We're only going to store a fairly small number of titles in this particular table. So thinking back to the data types we had available for numbers, we had things like int, which stores a number up to about 2.147 billion, which is a little bit excessive for what we need here. We could get away, I suppose, in this case, probably with a tiny int. Now, tiny int stores a value up to 255, which should be sufficient for all the possible titles. I can't think of many more than about, I don't know, 10-ish, I suppose. If you want to give yourself a bit of a safety net, and we talked about this idea in the previous video, where you sometimes use a larger data type than is actually required at the moment, just for future proofing. So I'm going to go over and I'm going to choose small int for this particular example. That gives me a max value of about 32,767, which is way more than I really need, but that's what I'm going to go for in this video. Now, the most important thing about this title ID column is that the individual values in each row are unique to the table, so each number for the title ID will appear once and once only in the title table. You could do that manually by just making sure you type in a unique number in each row, but it's much more convenient in SQL Server to have the table do that for us automatically. So to achieve that, we can create something called an identity column. So with this row still selected in the table design view, we're going to head down to the column properties area, and I'm just going to resize this so I can see a little bit more clearly what I'm about to do. I'm then going to scroll down into the identity specification section. So if I scroll down the list, there's a little section here starting with the words identity specification. To set the individual properties in this section, you'll need to click on the little arrow symbol that appears to the left, just to expand the individual properties. And the first property in there is called isIdentity. So currently this column that I have selected up here isn't actually an identity column. So I'm just going to flip that from no to yes, and the quickest way to do that is just to double click on the word no, and that will switch it to the value yes. You could of course just use the drop down arrow to do that. That will automatically populate a couple of other columns or a couple of other properties. You've got identity increment and identity seed. So seed represents the first number that will appear on the first row of data you add to the table, and then increment indicates how much the value will increase for each new row that you insert. In the real world, I've never seen any reason to use anything other than 1 and 1. One of the ideas behind the ID columns is that they should almost be a meaningless value to you. It's not important that you know what these numbers are. This is a value used by SQL Server that eventually we'll use to join or relate the two tables involved. So I'm going to leave those set as 1 and 1 for the time being, and that will make sure that each new row that we create in this table will have a unique value assigned to the title ID column. The final thing we're going to do to the title ID column is tell the table that this is the unique identifier, or in database terms, the primary key for the table. You can assign a primary key to a table in a couple of different ways, but one convenient way is just to right-click on the little grey box to the left of the column definition, and then choose the option there that says Set Primary Key. You should see that little key symbol appears next to the option in the menu. If I choose Set Primary Key, you'll also see the little gold key symbol appears next to that column definition in the table design view. So the primary key is the unique identifier for this table. It guarantees that every value in that column will be completely unique in the scope of that table. The only other thing that we need to do in this table then is define the column which contains the title text. So I'm going to create a new column there called title, and this one's really simple. All we really need to do here is assign the correct data type. So the titles of people can be variable length strings, can't they? They're not fixed in width, so we're going to use nvarchar, and the default value there is 50, which seems a bit excessive actually. I can't think of many titles over more than about 10-ish characters, so that's set a limit, a relatively low limit there of 10 characters as the max length. Now, it's highly unlikely we're going to be creating any rows in this table without actually assigning a title, so we don't want to allow nulls for the title columns. Let's uncheck that box, and then finally we can just save this table and give it a sensible name. So I'm going to call this table title, and then click OK to save it, and now we're ready to start entering some data into it. So just as before, what we're going to do is first of all refresh the tables folder by right-clicking and choosing refresh, and then we should find our title table has appeared, and I can right-click on that table and then I can choose to edit top 200 rows. So you'll see we've got these two columns, title ID and title. You'll see that if you click into the title ID column, this is a little bit innocuous, it's not very obvious that this pops up, but down in the message bar down at the bottom it says cell is read only, which means that if I try to type in a value, you'll see that I can't do that. It doesn't matter what I try to type in, that value will be assigned automatically. So I can click into the title column, and let's just type in a few basic titles. I'm going to go with Mr. and then let's say Mrs. And you'll see that for each row that I add in here, the ID number is assigned automatically. So we don't really care what that number happens to be. We just carry on happily adding new rows of data, and then those each row will be assigned a unique number. Let's just add one more single one, and I think that will probably do for this table. So at this point I'd like to go back to the design view of the person table. I've actually left that tab open so I can click on the tab at the top to go back to the design view, otherwise you'll have to right click on the person table and choose design. We're going to create a new column in here which is going to store the ID number of the title we'd like to assign to each person. So unlike the title column we created earlier on, all we're going to do here is create a title ID column. It's conventional for the column in the other table to have the same name as the primary key column in the original table, so we created a column called title ID in the title table, so conventionally we call that title ID in the person table as well. Sometimes you'll find databases where this column is preceded or prefixed with the name of the table to which it belongs, so person title ID, just to distinguish it from the original title ID column. But I'm not going to do that in this case. I'm going to stick with this convention of using the exact same name. The other really important thing is that we use the same data type for this column as we did for the original title ID column. So that, if you remember, was a small int. So I'm going to use exactly the same data type for this one as well. I'm going to call this one small int. We can now take that basic same approach to creating the company table and the hobby table. So let's go through that relatively quickly. Let's right-click the tables folder, and I'm going to choose New Table, and this one's going to be the hobby table. So I'm going to call this one Hobby ID for the first column. Its data type, I can't think of that many hobbies we're going to be adding into this particular table. We could use small int for the ID. Well, it's unlikely we're going to have more than 32,767 rows. But tell you what, just for the sake of example, let's use an int data type for this one. This gives us a maximum of about 2.147 billion, which we're never going to fill up, certainly not in the scope of this video anyway. So we'll use an int column for that, or an int data type for that column. We're going to make sure that we don't have to assign the hobby ID ourselves. I want that to be generated automatically. So again, I'm going to go down to the column properties area, and I'm going to scroll down to the identity specification section. I can click the little arrow to the left of that to expand it, and then change the isIdentity property from no to yes, just by double clicking. I'm going to use a seed of 1 and an increment of 1. I've never seen any other reason to use anything other than that. So it's fine that we'll generate similar numbers. So we're going to generate the first row in this table will have an ID of 1, which is of course the same as the original title ID we added. But the important thing here is that it's unique in this table. So the number 1 will only appear once in the hobby table. I'm also going to make sure that this is the primary key for the table. So I'm going to right click on that column and choose Set Primary Key. And then the only other column I think we'll have in the hobby table is going to be called hobby. And this one's going to store the actual text of the hobby name. So let's call this one, let's use nvarchar, and maybe 50 maybe is a bit too short this time. Let's maybe increase this to 100. So the max value, or the max length of any string in the hobby column will be 100 characters. Again, I wouldn't want to add a row into this table unless I was actually adding a new hobby name. So I'm going to uncheck the allow nulls box, and that's the hobby table basically created. So I'm going to save this table now, and I'm going to give it a sensible name. I'm going to call this one hobby, and then click OK to save it. I'm just going to close down the hobby tables design view at this point, and then I'm going to right click on the tables folder and refresh it, and then I'm going to right click on the hobby table and choose edit top 200 rows. Again, I can't type in any ID numbers, those are assigned automatically, but I can type in some hobby names. So what were the two that we had in earlier on? We had creating training videos. Not a very exciting hobby, but there you go. Probably just about more exciting than ferrying kids to events. We could also have a few more exciting events, like, I don't know, zorbing. I don't know if you've found that one before. Have a quick Google of that. That looks like quite a lot of fun. I kind of fancy trying that one myself. I met a guy on a course recently who was training to be a helicopter pilot, so maybe taking helicopter lessons. I was quite jealous of that guy. But anyway, there we go, helicopter lessons. I don't know, we could always come back and add in some more hobbies a bit later on. Maybe some sporty things. Let's have, like, I don't know, let's say karate. I do karate myself. And then, I don't know, what else could we have? Walking the dog. I don't actually have a dog, but there you go, let's pretend we've got a dog. So there you go, there's a few hobbies we could assign to people later on. I'm going to leave this table open for now so we can quickly see its values a bit later on. Then we've got one more table to create at this point, which is the company table. So let's create the company table in much the same way. I'm going to right click on the tables folder and then choose new and choose table. Let's go through this relatively quickly. We'll of course have a company ID, and that is going to be an int in this table, and I'm going to make sure that that's an identity column. So I'm going to use the column properties area, find the identity specification section, expand that, and then double click on the no to change isIdentity to yes and fill in the increment and the seed. I also want to ensure that this is the primary key for the table, so I can right click next to it and choose set primary key. And then we can enter values like, or columns like company name, I suppose. So should I call this company name or just name? Let's call it company name for now. So I'm going to call this one company name, and then we'll say nvarchar, and we should make sure that there's enough scope for entering quite long strings. Let's enter that. Let's enter a max of 150. And it's unlikely we'll enter a company without knowing its name, so let's remove the allow nulls check as well. Next, let's have a couple of other columns of data related to a company as well. So your extra tables that we're creating here aren't just about storing an ID number and a name. They can also store other related information about the item in that table. So a company has all sorts of other interesting bits of information, doesn't it? So let's say maybe there's a website address or a URL. I'll call it website, and in there we'll just store the web address of the company's website. So I'm going to say that's nvarchar. Let's say 150 for that one as well, just in case. And then I might not know the ID or sorry, the URL of the website, so I'll leave that one as allow nulls. What else could we do? I guess we could store things like which sector the company is or belongs to. So I could say sector, and again in this case I'd say nvarchar, so I'd store it as text. Let's say nvarchar 100 or something along those lines. And then we could do some numbers as well. We could say number of employees, I suppose. Let's just say rough number of employees. So we've got another number we could store in there. But hopefully you get the idea here. You can store as many other useful categories of information about a single entity in a table as you like. It's not always just about storing the ID number and the bit of text representing the item's name. So for the employees, let's be ambitious. Let's say we can have companies with up to 2.147 billion employees. Wisal sadly isn't quite that big these days, but we'll assume that we have companies in the database that might. So having done all of that, let's save the table to create it, and I'm going to just hit the save button, and I'm going to call the table company, and then we can click OK or hit enter to create that table. I'm then going to close down the design view of that table, and then I'm going to go back to the tables folder and right click and refresh, and then I'm going to right click on the company table and choose edit top 200 rows. Okay, so let's just have a couple of simple companies entered into here. I'm going to put Wisal Training in, of course, because I've got a couple of employees already added to my person table who work for Wisal Training. So let's put in Wisal Training. I'll try and spell it properly. I should be able to do that by now. I've worked with the company for long enough. And then the website, well, hopefully you guys already know all that from all these wonderful videos that you've watched, www.wisal.co.uk. So I almost forgot that myself then. Then the sector, I guess we can set the sector to IT, just for something quick and convenient. And number of employees, let's pretend Wisal Training was a massive multinational organisation with hundreds of thousands of people. Let's say there's a million people working for Wisal. If only there were. Okay, for the time being, I'm just going to leave it as one single company, and what we need to do now is just go back to the design of the person table again. So I'm going to go back to the person table design view, and we're going to add in a couple of extra columns that allow us to connect to the hobby and the company. So just like we did for title ID, I'm going to create a column called hobby ID, and then I'm going to change the data type of that to match the primary key column in the hobby table, which we decided was an int. And then finally I'm going to have company ID, and again the same sort of idea, company ID, not just company. And then I'm going to make sure that the data type of that is also matching the primary key column in the company table, which was int as well. So at this point we're pretty much ready to start entering data back into the person table. Before I do that, I'm just going to quickly save the table, so I'm going to hit the save button at the top, and I've got these new columns available now. So what I should be able to do is right click on the person table in the tables folder and choose edit top 200 rows. So we should see now that we've got our two people, but with these extra columns available. And I've got the ability now to assign a title and a hobby and a company to the person by entering not the actual raw text of the title and hobby and company name, but the ID number that corresponds to those items. So this is where things get a little bit awkward. SQL Server's not really, or Management Studio at least, isn't really designed for manually entering data in this fashion. It's not quite as fancy as you might have seen in maybe Microsoft Access, where you get lovely little drop-down lists created where you can select from a list of all the available titles. SQL Server Management Studio isn't designed like that. It's not designed as an end-user tool. It's a development tool. So to enter the values manually, and you rarely do this in SQL Server, I have to admit, but to enter the values manually, you need to know what the ID number of the title ID actually is. So let's just have a quick look back at my title table, and I entered the value, or the title of Mr. was row number 1 in that table, so the title ID is the number 1. So let's go back to the person table, and I'm going to enter a title ID of 1 for both myself and for Andy. Then the hobby IDs, again, I created hobby IDs. If I go back to the hobby table, which I left open, I've got creating training videos, which is the number 1, and ferrying kids to events is number 2. I might change my hobby actually. I'm going to go for karate this. I'm going to go for number 5 for me and number 2 for Andy. So let's go back to that table, and I'll stick in number 5 for me and number 2 for Andy. And then finally the company ID. We both work for Wisal, so there's only one ID number in that table. That's a fairly easy choice. So it's not the simplest way to enter data, of course, you need to be able to link the ID numbers to the actual underlying values. But this is the way the data is actually stored. This is much more efficient than storing the same company name multiple times. So it essentially solves all those problems we had right at the start of the video when we first designed the person table. Now, there is one fairly major potential problem with the way we've created our table so far. Although we've kind of solved some of the problems associated with duplicating data in a database, there are issues to do with what values we are allowed to enter into each of these ID columns in the person table. Although we know that when we're entering data, we should be assigning an ID number that's related to one of the rows in each of the tables, there's actually nothing to stop us from entering any value we like, as long as it corresponds, or at least it fits in with the data type of that column. So the company ID is set as an integer, which means I can put in any value from negative 2.147 billion to positive 2.147 billion. So if I just entered a number like so, there's absolutely nothing to stop me from storing that value as the company ID next to an individual person. Now obviously if I come to query the database and I'm trying to query which company Andy Brown works for, this gives us complete nonsense. There is no company with an ID number of 1, 2, 3, 4, 5, 6, 7. So I won't get any meaningful data out of the database. What we need to do now, if I just switch this back to the value 1, what we need to do now is create some kind of system that prevents us from adding invalid company IDs, hobby IDs and title IDs. So the next little part of the video is going to get into creating relationships between tables. To begin with then, I'm just going to go back to the design view of the person table. So one simple way to do that, I've left the tab open over here at the right hand side, so I can click back onto that tab, and then I just want to close down all of my other tabs for the moment, just to tidy things up. Nice little technique you can use in SQL Server Management Studio. If you right click on an existing tab, you can choose to close every single one of the tabs by choosing close all documents, or just close everything except for this one. So I'm going to choose close all but this, which just tidies up my screen a little bit. Now essentially what we're going to do here, to restrict the values that can be entered into these three columns, we're going to add some kind of constraint to the table. Now we looked at the basic idea of check constraints in the previous video. So that was for things like if you've got a particular column like date of birth, you can restrict the values entered into that column by saying the date of birth must be less than or equal to today's date, which was the example we did in the previous video. Now check constraints aren't particularly useful for creating these relationships between different tables. What we need to do is add something called a foreign key constraint. So we've talked about the idea of primary keys. We're also going to add a foreign key. In fact, we're going to add 3 foreign keys to this person table. We'll start by adding the foreign key related to the title ID column. So we want to restrict the values in the title ID column of the person table to only accepting title IDs that already exist in the title table. Just to help us out with this, I'm just going to expand a couple of items in the database or the Object Explorer window. So I'm going to expand the person table and then expand the columns folder. And then I'm going to do the same thing for the title table. I'm going to expand the title table and then expand its columns folder there as well. So just a couple of little indicators that you can see here. Hopefully you can see from the screen that the title ID has this little gold key symbol listed next to it, and the letters PK indicating it's the primary key for the table. So this will just help us when we start creating our first relationship. So there are a couple of different ways of creating foreign key constraints and relationships in SQL Server. There's one fairly tedious, slightly awkward way to do it using a dialog box, and then there's a much more exciting dynamic way to do it using something called a database diagram. I'm going to show you the boring way first, just so you can appreciate the more exciting way to do that when we get onto it. So to start with, let's make sure we've reactivated the table design view, and then let's head up to the table designer menu at the top of the screen. From there we can choose the option that says relationships, and that'll open up a dialog box allowing us to add any foreign key relationships to this table. We'll need to click the add button to add a new relationship to the list, so let's do that now, and that gives us a new relationship called FK, short for foreign key of course, just to distinguish it from a primary key, person to person. So the default name isn't particularly good here. The idea behind the foreign key names is it's designed to refer to the individual tables involved in the relationship. So here we're essentially referring the person table to the person table, which isn't quite right. I'm actually just going to start by renaming this, so it's called FK person title. So we know these are the names of the 2 tables involved. What we now need to do, in the most important part of the relationship, is defining which columns are involved and which tables are involved. So there's a little section here that says Tables and Columns Specification. And if I click the little arrow to the left of that, it'll expand into a set of properties. The way that we're going to set these then is using this little ellipsis button, the dot dot dot. If you click on that, you'll get another dialog box popping up. So it shows you the relationship name again, as we've modified it, person to title, and it lets you choose the two tables involved using the drop-down lists. Well, technically it lets you choose one table. We're adding a foreign key to the person table, so that option is locked out. We can't change that. We're adding this foreign key relationship to the person table. What we do need to do is choose which table contains the primary key that we're linking it to. So primary keys are important in relationships. You can create a foreign key linked to the primary key of another table. So let's choose from this drop-down list the title table, and we know, because we can see that here in the Object Explorer, that the title ID is the primary key column. So if you've chosen the title table, we can use the drop-down list down below to choose title ID. Then we need to choose which column that will be linked to, or related to, I should say, in the person table. So again, there's a drop-down list that you can use to link the title ID to the title ID column. This is kind of a nice convention. It's very, very easy to spot which columns you're going to relate, because they have the exact same names in different tables. So at that point I'm going to click OK, just to take us back to the main part of the dialog box, and that shows you that it's filled in all of these sub-properties. There's one last thing that I do want to ensure here. If I scroll down the list of properties down towards the bottom, there's an option here that says Enforce Foreign Key Constraint. Now, the whole reason we're creating this relationship in the first place is to ensure that we can only add ID numbers in the person table if the corresponding ID already exists in the related table. So having this property set to yes, Enforce Foreign Key Constraint, will ensure that that's the case. Now, there are one or two slightly more subtle implications for what we're about to do here. We've just said that in order for a value to be stored in the title ID column of the person table, that value must exist in the title ID column of the title table. That's basically what the foreign key constraint is doing. That has implications if we then try to either delete or update the ID number in the original title ID column of the title table. There's a little section here that allows us to specify what happens if I expand the insert and update specification. There are two rules, delete rule and update rule. Now, both of these are set to no action by default. So what that means is, once I've set up this foreign key constraint, I'm no longer allowed to delete or update ID values in the title ID column of the title table, because that's already been connected to values in the person table. That's what no action means. If you try to delete anything, you'll be provided with a warning, and you will not be allowed to do that. There are a couple of other options available for both delete and update. So if I click on the drop-down arrow next to update, the really, really dangerous one here is called cascade. So what that means is, if I choose Cascade, it means I will be allowed to delete rows from the title table. So for instance, let's imagine I deleted title ID number 1 corresponding to the title Mr. from the title table. If I had this option delete rule set to Cascade, what that would mean is that every single relationship pointing to that title ID in the title table, so in this case the title ID, every row in the person table with a title ID of the number 1 would be deleted. Now bear in mind, this isn't just the value of that column, not just the title ID column, it's the entire row of data where the title ID was equal to the title ID that had been deleted. That's horrifically dangerous. We definitely don't want to set that one in this particular example. There are a couple of other possibilities here as well. There's an option there that says set null. So if I deleted title ID number 1 from the title table, I could set the title ID in the person table to just have a null in place of its number 1. Of course, you must have that set to allow nulls, and in fact, you must allow all foreign keys in the table to allow nulls for that to work. Set default, if you've assigned a default value to the title ID column, and indeed all the other foreign key columns, then that will set the default value for that column, so it will replace the 1 with whichever was the default value. Similar options there for the update rule. We're not going to change these at this point. We're just going to accept that once we've assigned a title ID of 1 to the title ID column of the person table, we'll no longer be able to delete or modify that in the original title table. So, having gone through all that boring detail, all I'm going to do now is click the close button to close down that dialog box, and then just save the table to create that foreign key constraint. You'll be warned that this is going to affect both tables involved in the relationship, and that's absolutely fine. So at this point I'm going to click yes to save that, and I've got my first foreign key constraint created. You can check that your foreign key exists in a couple of different ways. If we choose to refresh the columns of the person table, I'm going to right click on columns and choose refresh, and then you should see now that the title ID column's got this little silver key symbol listed next to it, as well as the letters FK. So that's a clear indication that key definitely exists. You should also be able to see that in the keys folder, which if I expand the keys folder, it shows me that I've got a foreign key in the person table. I should have shown you that earlier on as well, I suppose, for the title table. If I expand the keys folder in the title table, it shows me I've got a primary key there called title. The real test, though, that this foreign key constraint is actually working is if I try to enter data into the title ID column of the person table with a title ID that doesn't exist yet in the title table. So let's just right click on my person table. I'm going to choose edit top 200 rows, and a really quick simple test is to find the title ID next to any person and enter a value that we know doesn't exist in the title table. If I try to enter that value next to my title ID, as soon as I try to click away from that row, I'll be warned that that breaks or conflicts with my foreign key constraint. So that's essentially achieved the end result that we wanted, admittedly in a fairly tedious, awkward way. I'm going to just hit the escape key on my keyboard to abandon the change I was making to that record, or that row, and then I'm going to close down the datasheet view of the person table. So that was a fairly boring, tedious way to create foreign key constraints. The much more exciting way to do this is to use something called a database diagram, which is essentially a visual tool to help you picture the different relationships and foreign key constraints in your database. Even with the best naming conventions in the world, in a real-world database, when you're creating lots and lots of tables and lots of relationships, it can be quite difficult to keep track of the individual relationships between tables in a rigid structured view like this one here. So what we're going to do next is create a database diagram that allows us to create essentially a picture of the relationships in the database. I'll start by closing down the person table, and then I'm going to start by right-clicking on the database diagrams folder. I can then choose New Database Diagram, and somewhat annoyingly for me, I get an error message related to not being able to return information about the particular account that I'm logged in with. Now this is a particular issue for me to do with a domain connected user account that I'm using for this particular machine on which I'm recording the video. I'm not currently connected to the domain for which this user is a part of. So I'm going to click OK on that error message. I leave this in here just mainly in case you encounter the same sort of issue in the real world. Hopefully you won't. In the office, when I'm actually connected to the YSL domain, I don't encounter this issue. One quick simple way to get around this at this point, and this affects me on training courses as well, is to change the owner of the database. So I'm going to right click on the people database, and then I'm going to choose properties. And then on the dialog box that pops up, I'm going to head into the files folder, and then I'm just going to choose or change the owner of the database from a domain connected Windows account to the default system administrator account, which is called SA. At that point then, if I click OK, I can then right click on my database diagrams folder again, and then choose New Database Diagram. And this time I'll get a slightly different message. This one's not an error message, this is just informing me that the database needs to install a couple of extra support objects. So these are actually system stored procedures that will be created to enable me to create database diagrams. So at this point I'm going to click Yes to allow that to happen, and then I'll be taken into the New Database Diagram view. The first thing that I'm asked to do is choose which tables I want to add into the diagram. Now I can always come back and add more tables in later on, but for this simple example I want to add in every single table that belongs to my database so far. So the simplest thing to do here is just drag a box that encloses all 4 tables and then click the Add button. And you ought to see in the background all those tables get added in to the diagram view. At that point I'm going to click the Close button just to close down the Add Table window, and hopefully you'll see a few different things have happened in the background here. So I've got my title and person table, and there's already a relationship being shown here between these two tables. So that's related to the foreign key that we've created. In fact, if I hover the mouse over that line, you can see it tells me that it's relationship FK person title, which is the name we gave to our relationship earlier on. I'm just going to rearrange a few of the items in my diagram view just to make things a little bit easier to read. So I'm going to move my person table across by clicking and dragging on its title, and then I'm going to position the title table up towards the top left hand corner just by clicking and dragging again. I'm then going to move my hobby table down a little bit, and then I'm going to move the company table down to the bottom of the list. So I'm kind of arranging my tables in the order in which the columns appear in the person table. Now, as well as moving the tables themselves around, you've got a bit of control over the lines as well. I'm just going to move my title table up more towards the top left-hand corner, and then drag the person table up a little bit as well. You'll see the lines kind of redraw themselves a little bit when you move the tables around. Now, when you've got a kink in the line like this, you can actually click and drag on different parts just to try to attempt to point the lines to the columns that they're related to. This isn't a requirement by any means at all. This is just for people who are easily irritated by messy layouts like me. You can rearrange the diagram just to try to make it look a little bit cleaner and clearer. You don't affect anything just by moving the positions of these lines at all. In fact, some people think that's a complete waste of time, because if you decide to start moving the tables around again, then all the lines redraw themselves anyway. So if I move the person table around to such an extent, then the line redraws itself, and then if I move that around again, it points to the completely wrong place. So this is one of those things that really irritates me about this view. But anyway, the reason we're here is not to fiddle around with lines. The reason we're here is to create relationships between the remaining tables in the database. Creating relationships in the diagram view is pretty straightforward. All you need to do is click and drag a primary key column onto the related foreign key column. So from the hobby table, I can click and drag the hobby ID, the primary key, again indicated by this little gold key symbol. I can click and drag on that and then just drop it on top of the hobby ID column in the person table. Now, if I position that correctly when I release the mouse button, the same dialog boxes we've just seen reappear, but it's already populated the primary key table, which is hobby, and the foreign key table, which is person, and hopefully it's also selected the correct column names, hobby ID and hobby ID. If it hadn't selected the correct columns, that's not a problem at all. You can just use the drop-down lists to select the correct columns. If I click OK on that first dialog box, that takes me to the same dialog box we've seen previously, and again we've got a name for the new constraint or relationship. It's called FK person hobby, and we've got the same enforce foreign key constraint set to yes, and the insert and update specifications set to no actions. So if I click OK at that point, that's going to create a new relationship. Now you can see, hopefully you get a little asterisk symbol appearing next to the table names. This indicates you've made a change to the table that hasn't yet been saved. But just before we save these objects, let's create the company relationship as well. I'm going to click and drag between the company table, company ID, onto company ID, and then I see the same dialog box pops up, company table to person table, company ID to company ID, with a sensible name, FK person company. I can click OK, enforce foreign key constraint, yes, and the insert and update specifications are set to no action. So click OK again, and we've got another change made to two tables, indicated by the asterisks. Just before we do save the diagram and save any changes to the tables we've created, it's worthwhile quickly mentioning the different symbols you'll see on the relationship lines. So hopefully the little gold key symbol at one end of the relationship is fairly obvious. That represents the table that stores the primary key value, so where the data is actually coming from. The symbol at the other end is supposedly the symbol for infinity, and the reason it's the symbol for infinity is to do with the type of relationship we're creating. In database design, relational database design, there's a particular type of important relationship referred to as a one-to-many relationship. So it's termed one-to-many because at one end of the relationship, the value in the connected column or the related column can only appear once and once only in that table. So the title IDs, for instance, each title ID can appear once and once only in the title table. In the person table, however, each title ID can appear many times. So in the person table I'm going to have many Misters and many Mrs., etc., etc. So the type of relationship is referred to as a one-to-many relationship. Bear that in mind for the next little part of the video, one-to-many relationships. Values appearing once in one table, but many times in another table. So, having just explained that, let's just quickly close and save this diagram, or in fact, let's just save it rather than close it, so we can save it in this traditional way. You can give your diagrams a sensible name. I'm just going to call this people diagram, and then click OK to save the diagram. At that point, again, you'll be warned about any tables that are affected by this diagram, so I'm going to click yes, I'd like to save changes to all those. At that point, all the asterisks should disappear, and then if we drilled through into the tables folder of the people database and had a look at, first of all, the person table, I suppose, and look in the columns folder in there, if we refresh that columns folder, and then we should see that the silver key symbols appear next to every foreign key constraint column. We can do the same thing for the keys folder, and if we refresh the keys folder, we'll find that all three foreign keys appear in there as well. Now, once you understand the basics of one-to-many relationships, you'll start to spot lots of other opportunities in your database designs for adding these relationships in. So for example, in the company table earlier on, we added a sector column, and in there we stored the sector name that the company belongs to. So Wiseowl was put into the IT sector. Now, of course, in the real world, lots of companies are in the IT sector, so that suggests that you might find yourself entering the same sector name in the company table multiple times. And as we know by now, that's pretty bad practice for relational database design. So what we're going to do is we're going to modify the design of the company table to extract the sector column and create a separate table called sector, and then connect that table or relate that table to the company table via a foreign key constraint. One of the other cool things about the diagram view is that you can also use it to modify the design of tables. So should I want to delete the sector column from the company table, I can happily just right-click on it and choose to delete the column, just as I could in the table's design view. At that point, I could just choose to save the changes I've made to the company table by clicking the Save button, and that will warn me I'm about to save changes to the company table, which is fine, and I can click Yes to achieve that. I can also create completely new tables in the diagram view. I can do that just by right-clicking somewhere in the background of the diagram, and then I can choose the option that says New Table. I've also got a toolbar, by the way, up at the top right-hand corner when I'm in the diagram view that gives me options for all of these things I'm about to do here. But let's choose New Table. I've got to give the table a name to start with, so let's call this new table Sector, and then I can click OK to create a new table in Table Design View, so I can actually switch any existing table into the table design view as well. If I right-clicked on the company table, I could choose Table View and choose Standard, so that takes me into essentially a small version of the table designer tool, and I can then right-click on that and choose to switch it back to the column names view. So in the sector table, what I'm going to do is create two new columns, just in the same way we did earlier on. I'm going to create a column called Sector ID, and then I'll set its data type so that it uses data type of int just for convenience. I want to make sure that this is the primary key for the table, so I can right-click on that and I can choose Set Primary Key. And then I'm going to create a new column called Sector, which will have nvarchar, let's say nvarchar 100, let's say. And we don't want to allow nulls for that one either, so I'll uncheck the Allow Nulls box for that table as well. For that column as well. One other thing that we did in the previous tables is we set their ID columns to be identity columns, meaning they assigned a value automatically, so we didn't have to type one in. Now, there's no way to do it apparently here at this point in the sector table because we don't have the column properties area down at the bottom of the designer. But we can actually display that just by right-clicking anywhere inside the sector table and choosing to view Properties. That will open up the Properties window on the right-hand side of the screen, and if I select the Sector ID column, it will show me properties of that column. So in there you can find the identity specification, and you can expand that, and then double click again on the No keyword there to set that to yes, and set the identity increment and seed to 1. At that point, all I need to do is save the table. So again, I'm just going to go back to the Save button at the top of the screen and choose to save it, and that will warn me about saving changes to, sorry, beg pardon, if I actually click into the diagram part of the screen and then choose to save it, that will warn me about saving the changes to the sector table, and then I can click Yes. And that table is now saved as part of the database. In fact, if I refresh the tables folder, I can find I've got my sector table sitting there just as though I designed it in the standard table designer. I'm just going to switch the sector table view to the column names view just to make it look like all the other tables, and then reposition that in the diagram just below the company table. Next, I need to add in a new column to the company table which can hold the sector ID. So I'm going to switch the company table back to the standard view, which takes me into the designer effectively, and create a new column in there called sector ID. The data type of that will have to match the primary key column from the sector table, so that will be int, and I'm going to allow nulls. Having done that, I'm just going to switch the table back to the column names view, and then again save that. So again, that will affect the company table. I can click yes, and then all I need to do, still from the same view, just the same diagram view, I can click and drag sector ID to sector ID in the two different tables, make sure that I've got the correct table selected, company to sector, matching the sector ID to sector ID, and then I can click OK. I want to enforce the foreign key constraint, and then I can just check that I've got delete and update set to no action, and then click OK to create yet another new relationship. Again, the tables there won't be won't be saved yet. You'll see the little asterisk symbols indicating that these tables haven't yet been saved. So if I just hit the save button one more time, that will save the changes I've made to both sector and company. Just to wrap up this little section, we could add some data to the sector table and then assign the correct ID to the company in the company table. So let's head into the sector table first. We can right click on it in the Object Explorer and choose Edit Top 200 Rows. And then again, of course, we can't enter an ID because that's an identity column, but we can enter the name of the sector. So let's call this one IT, nice and simple. At that point, I'm just going to save that row just by clicking onto a different row in the table and then close that one down. I can then do the same thing if I find the company table. I can right click on that and then edit top 200 rows. There's only one company in there, so I know that the ID for the sector for that company is the only ID number added to the sector table so far. That's the number 1, and I can happily save that just by clicking onto a different row. Just to check that the foreign key constraint is working, I could try to enter a different number, one that doesn't yet exist in the sector table, and if I try to save that, it would tell me that that row has not been committed because it conflicts with the foreign key constraint. So that's fine. I can just hit escape to abandon that change and then close down the company table, and those are the relationships essentially set up. So we've modelled some fairly simple one-to-many relationships in the database, and one-to-many relationships are relatively simple to understand. There are lots of examples of those in the real world, of course. So one sector can contain many companies, and one company can contain many people, and so on. But in the real world, there are also examples of relationships that are slightly trickier to model in a database diagram. So for example, the relationship between the person and the hobby. Currently, many people can perform the same hobby, but the way we've modelled the data so far, we don't have a convenient way for one person to perform more than one hobby. So for exciting, interesting people, more so than me, I guess, who might do lots and lots of interesting, exciting things at the weekend, we've got no way to model anything other than just one single hobby so far. If we wanted a person to have more than one hobby, currently, the only option we've got with the way our database is designed is in the person table. If I just edit the top 200 rows, so let's say Andy Brown takes up, I don't know, kite surfing or something like that. As long as we'd added kite surfing to the hobby table, we'd have to then enter all of Andy Brown's details again to the next row of the table, just so that we could assign a new hobby ID to him. And that's really, really not the correct way to go. One fairly standard response to this sort of situation, but definitely not the right way to go, by the way, is to say, well, let's say we'll give a person a maximum of 5 hobbies they can do. We could redesign the table so that we have hobby ID 1, hobby ID 2, etc, 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 so that we create a separate column for each hobby a person might have. But that's a really poor way to design the table. First of all, boring people like me would only have one hobby in the first place, so that we'd have lots of wasted columns. Secondly, really exciting people like maybe you've got lots and lots of hobbies that you do, you'd need more than just those 5 columns, so we'd need to redesign the table again. So that's a really terrible way to design the table. So let's have a quick look at what the actual real proper answer to this sort of situation is. How do you model a many-to-many relationship in a relational database? The simple idea here is to create more one-to-many relationships. That's almost always the solution to modelling real-world situations in a SQL Server or any relational database. So in the real world, although there are lots of examples of many-to-many relationship, so one hobby can be performed by many people and one person can have many hobbies. In database design, that has to be broken into separate one-to-many relationships. So what we're going to do is create a combination of a single person and a single hobby in what's often referred to as a junction table. So first job to do is to remove this current relationship between the hobby and the person table. If I try to do that, I can just right-click on the relationship and choose Delete Relationships from Database. If I do that, I'll be asked to confirm it. If I click Yes to remove that relationship, you'll see that that relationship has now disappeared. Now, of course, that's made a change to the hobby and the person table, so at this point I'm going to try to save that. It'll warn me that I'm going to save changes to both the hobby and the person table, which is fine, and then I can click Yes. What I'm then going to do is move the hobby table over to just below the person table. So that just gives me an easy way to create a couple of extra relationships to a new table that we haven't yet created. Before I do that, I'm also going to remove the hobby ID column from the person table. So although there's already data in there, that's fine for this example. There's only 2 rows of data, so I'm not losing too much here. So I'm going to right click on the hobby ID column in the person table and choose to delete that column. And again, having made a change to that table, I'm just going to save the diagram again to update the changes to the person table. The next thing I'm going to do is create a new table which will store the combination of person and hobby. So I can do that in the same way as I did earlier on. I'm going to right click somewhere in the background of the diagram view and choose new table. I'm going to call this table person hobby, and then if I click OK, that'll open up the table, allow me to add columns to it. So the columns we're going to create in here, we're going to have an ID column, of course, so essentially every table in a database should ideally have a primary key column. You can never guarantee in the future when you might choose to create new relationships. So we've got one obvious exception to that currently. The person table doesn't have a primary key, so we'll solve that one shortly. But for now we'll have a person hobby ID column. So that's just going to store the ID number of the individual combination of person and hobby. So person hobby ID, I'll set the data type to int, and we're not going to allow nulls here, but we're going to set that to be the primary key anyway, which will make that happen automatically. So if I choose set primary key, that removes the allow nulls check. I can then make sure that this is an identity column as well. So I can go to the identity specification section in the properties window and double click is identity, set that from no to yes. What I'm then going to do is store the person ID. So that's the ID of the person who will perform the hobby, and again we'll need to add that column into the person table shortly. We're going to have that as an int, so right now at this point I'm going to set that to be an int, and we don't want to allow nulls for that one. I'm then going to store the hobby ID as well, and again that has to be the same data type as the hobby ID column in the hobby table, so that was an int as well, and I don't want to allow nulls for that. Now currently all this table will contain is 3 columns of numbers, which won't be very meaningful to look at. So there might be various other columns you might choose to assign to this particular table. So let's say for instance you maybe want to state the date that you first started or took up that hobby. So let's say date started, and that column will be a date data type. Then maybe we can have, I don't know, let's say the number of hours you devote to that hobby per week, so I could say hours per week. And that can be one of the slightly smaller data types, so let's say that could be a tiny int. That gives us a maximum value of 255, which should be more than enough for a single week. And at that point all I'm going to do is save that table. In fact, I'm also going to switch it back into the column view. So I'm going to right click and choose table view, column names, and then I can save all the changes we made after I've just repositioned it over to the right hand side here. So having done all that, I'm going to save the diagram one more time to update that table. So let's just choose to save that and choose yes to confirm that I want to save the changes to the person hobby table. Okay, so there's one more change that we need to make before we can create the joins or the relationships to this junction table, and that's to ensure that the person table has a primary key column. So let's go back to the design view of that table. I'm going to right click on the person table and choose table view standard. I'm then going to insert a new column, so I'm going to do that at the top of the column list. It's not that important that it appears at the top, but it's conventional to have the primary key as the first column in the table. So I'm going to right click next to first name, and I'm going to choose insert column, which somewhat confusingly terminology wise inserts a row into the table designer, but there you go. So you're inserting a new column into the table itself. Let's call this column person ID. And I'm going to set the data type to an int, and I'm not going to allow nulls because this is going to be the primary key for the table. So I'm going to right click on person ID and choose set primary key, and I'd also like this to be an identity specification as well, or an identity column. So I can go to the properties window on the right hand side and expand the identity spec section and double click no to set is identity to yes. At that point I'm just going to change the table view back into the column names just to give myself a bit more space, and that's essentially the main change that we need to make to that table. Now at this point I need to save the changes that I've made to the person table, but that's going to lead me into a little issue. If I try to save my diagram at this point, I'm going to be warned that I can't save changes because the changes I've made require my table to be deleted and recreated, or dropped and recreated. So because of the change I've made to the person table, having added an identity column and a primary key after I've already added data to the table, I can't actually achieve that until I delete the table completely and recreate it from scratch. Now SQL Server can do that for me automatically and retain all the data that's stored in the table, but I have to tell SQL Server that I want to allow that in the first place. This is a potentially kind of dangerous thing to do. So by default, SQL Server prevents you from making these sorts of major modifications. So if I just click cancel on this save dialog box, and it warns me that I've just cancelled out of it, thanks for that, so I knew that because I just clicked cancel. What I can then do is go to the Tools menu at the top of the screen and choose Options. Now, there's a long list of options for SQL Server Management Studio, but the particular set of options we're interested in is somewhere down in the Designers section. So if I click Designers, there's actually a variety of different options available in here, but the ones we're interested in are Table and Database Designers, so these two pages are essentially the same page. The single option we're interested in is this one here that says Prevent saving changes that require table recreation. So this is a sensible sort of default setting for SQL Server Management Studio. If I simply uncheck that box and then click OK, I can then hit the Save button in the diagram, and it will warn me that I'm about to save 3 tables, company, title and person, and if I click Yes at that point, it has saved the table, added the primary key and the identity column, and retained all the data that was previously in there. Just to prove that, I can right click on the person table and choose Edit Top 200 Rows, and I'll see that I've got my existing data as well as the new person ID column. So let's close that one down and then just go back to the diagram view. All that remains then for this diagram is to create the relationships between person ID and person ID. So I can again click and drag my new person ID column to the person ID column in the person hobby table, and then make sure that I've connected the correct columns in the correct tables. Click OK, ensure all the settings are set. We know they are by now, so I can just click OK, and then do the same thing for the hobby ID to the hobby ID. Just confirm that we've selected the correct tables and correct columns. Click OK, and then finally save the diagram one more time. Confirm you want to update all the affected tables, click Yes, and those are all the relationships created. Just to quickly look at how to enter data into the person hobby table then, let's refresh the tables folder in the Object Explorer window, and then we can find our person hobby table. I'm just going to right click and choose to edit top 200 rows. And in fact, I'm also going to just open up the hobby table, so I'm going to right click hobby and choose edit top 200 rows there as well, just so I can remember what I put in there originally. It's been such a long time. So let's have a quick look. Right, so in the person hobby table, I can start assigning hobbies to individual people. So I know that I entered myself as person number 1 in the person table, so I can say person ID 1, and I can say hobby ID of, let's say, 1 as well. So I started creating training videos in about, when did I do that? About 2012, 2013? I can't remember when the first video I did was. Let's just say, for the sake of argument, 2013-01-01, and the hours per week I devote to that is a lot. Let's say, well, it depends on what the week is, I suppose. It depends on whether I'm travelling away for work or whether I'm at home. Let's just say, arbitrarily, let's say 10 hours. It's probably a bit more than that and a bit less than that in other weeks. Okay, so I've got another hobby as well, so I can say person ID number 1 and then hobby ID number, let's say 5, karate. So let's stick in hobby ID number 5, and I started that in about the year 2000-ish. Let's just say arbitrarily 2000-01-01, and then hours per week. Again, that kind of varies based on whether I'm travelling, but around about 4 hours a week, something like that. And then again, we can just carry on adding more and more hobbies for more and more different people. So if I want to add a hobby for Andy, I can put in his person ID of number 2, and his first hobby is ferrying kids to work. So I can enter the hobby ID of number 2, and how old are his kids? I don't know. I should know that really, but anyway, let's say let's say 2000-01-01. You get the idea at this point, I'm absolutely certain. We can carry on doing that now for every single combination of person and hobby. So now an individual person can have essentially an unlimited number of hobbies. According to our database diagram, one hobby can be performed by many people, and one person can have many hobbies. So we've got exactly the situation that we require. So this idea of using a junction table to model many-to-many relationships crops up in all sorts of places in the real world. You can imagine things like a person table that might be a customer table, and in a different database the hobby might be a product. So one person can order many products, but one product can also be ordered by many customers. So you could have legitimately a junction table that combines a particular person with a particular product in a single order. You might have a viewer table, so the person table could be a viewer, and the hobby table might be a YouTube video. So one person can watch many videos, but one video can be watched by many people. So again, there are lots and lots of examples of this sort of situation in the real world, and the standard way that you model that in a relational database is to use this idea of a junction table. So there you have it, there's the basic ideas and principles behind relational database design. Hopefully now you've got a reasonably good understanding of what's involved in deciding which tables are going to go into your database and how those tables should be related. And even if you find you're not in a position where you're designing your own databases from scratch in the real world, you should have at least a deeper understanding now of why databases look the way they do. So when you go back to the office and you start querying the database you're working with in the real world, you'll have a reasonably good understanding of why it's arranged the way it is. Hope that's been useful. Thanks for watching. See you next time. If you like what you've seen here, why not head over to the WiseOwl website, where you can find loads more free resources, including these videos, some written blogs and tutorials, and even some exercises that you can download to practice your skills. Thanks for watching. See you next time.